we're going to go over the combination circuit in practice 4, number 3. So first what we'll do is take a look at the table and kind of make sense of it. So we have 4 resistors here, and R1 is in branch 1, R2 is in branch 1. So that means that these two, this must be R1, R2, this will be 3, and 4. Okay, and since R1 and R2 are in the same branch, that these two will be following series rules. So whenever we are going to be looking at these two, they're going to be following in series rules, and everything else will be in parallel. Okay, and we know that the series rules is the voltage drop from the top to the bottom is going to add up to this total right over here. So we have 0 at the bottom after this resistor because it's got to get rid of everything. There's no resistor after it. And then it has a 7.2 drop. So that means from here to there is going to be 0. So something minus 7.2 is going to be 0, which is 7.2. Now 4.8 drop for the other resistor. We have 7.2 plus 4.8, which will give us 12. That means that there is a voltage drop of 12 all the way across. And that means our total is going to also be 12 volts. Now, when you drop 12, that means that after the resistor, there's going to be no more volts left. So that's 0 energy left, and it's going to go all the way back to the negative terminal of the battery. So what does this mean over here in our table? So we're going to work it out here. We have the current for 1 is going to be the 1 voltage over 1's resistance, which is 4.8 volts over 10 ohms, which is going to be 0.48 amps. And so we have 0.48 amps here. And we know that in series, it'll be the same current. So this will also be 0.48 amps. So in our circuit board, it will be 0.48 amps. All right, so next, let's figure out what the other branches are going to be. So we have over here 12 divided by 5. The current for 3 is going to be the current for the voltage of 3 over the resistance of 3, which is going to be 12 volts over 5 ohms. And when I put that into the calculator, I should get 2.4 amps. So then my current, my ammeter here for resistor 3 will read 2.4 amps. So now we're going to take the time to figure out what the resistance is for R2 and R4. All right, so R2 is just going to be voltage of 2 over current 2, which is 7.2 volts over 0.48 amps. When I plug that into the calculator, 7.2 over 0.48, I'm going to get 15 ohms. This is going to be 15 ohms. Next, I'm going to take R4 is going to be the voltage drop for 4 over resistance 4, which is, or sorry, not resistance, excuse me, current, which is 12 volts over 0.8 amps, which is going to give me, it'll also give me 15 ohms. So this will be 15 ohms. And so my current here will be 0.8. So my total will be 0.4. My total current will be 0.48 plus 2.4 plus 0.8. So I'm going to be adding the current here to get my total. So my total current will be 0.48 amps plus 2.4 amps plus 0.8 amps, which gives me 3.68 amps. So this will be 3.68 amps, and then plug into my calculator to find the total resistance. 12 divided by 3.68, so we have 12 volts over 3.68 amps. Okay, it'll give me 3.3 ohms. So next, let's go ahead and draw a schematic diagram. We have our battery, and we have an ammeter, and we have our resistor, our second resistor, then the ammeter for branch 1. We have the resistor for branch 2. Okay, we have our third branch. Then we have another ammeter. And then we're going to connect all of them together. And in our ammeter, we have 3.68 as our total. Then once again, this is 0.488. This is 2.4. Don't forget your units. And then 0.8 amps. And then the way we letter them is we're just going to letter them before and after each electrical component. So let me find a different color. Okay, so before here at the negative terminal, and then after. So before, then after, before, and after. And then maybe one at the after they all come back together. So this will be C prime, D prime, and then E prime and F prime, and then C double prime, D double prime, E double prime, and F double prime. And we're going to label it. Looks like we go up to G, A, B, C, D, E, F, G, and then back to A. And our maximum voltage is going to be 12, so we're going to just go by threes. All right. And it looks like at A, we're at 0. At B, we're at 12. C is at 12. And then D drops down to 7.2, so we're going to find 7.2, which might be around there. Okay. And then E, sorry, it doesn't drop. It drops to 7.2, so the first drop is 4.8, which will then land us over here at 7.2. All right. And so then D is at 7.2. E will also be at 7.2. And then F is when it gets down to 0. So F will be at 0, G is at 0, A is at 0. And so we're going to just go ahead and connect all of that together. Okay. Now for C prime, I'm going to go ahead and put that in a different color. C prime, if we notice, goes from 12 to 0. So C prime goes from 12 to 0. And then C double prime goes from 12 to 0 as well. So 12 all the way down to 0 for D. So that's how I would graph it. All right, so next we're going to fill out the power part. Remember, P is equal, so power is equal to the current times the voltage. Okay, so what we're going to do is have 12 times 3.68. So in my calculator, 12 times 3.68 is going to give us 44.16, and our unit will be watts. Then next row, 4.8 times 0.48 will give us 2.304, but we'll just round it to the nearest tenth. And we have 7.2 times 0.48, 7.2 times 0.48 is going to give us 3.456, which we'll just round to 3.5. And then we have 12 times 2.4, which will give us 28.8 watts. And then this one is 12 times 0.8, which should give us 9.6 watts. And then here we'll just put it in order from least to greatest. So we have this is the smallest, this is the next, third, and then fourth. So that is how you would do number 3 on practice 4.